Okay, let's talk about stacks. Stacks. Okay, what's that? Just like this picture, you can see that it's a pair of blocks, one putting on top of another one. So what's that mean? Okay, let's think about the definition. A stack is a container of objects that are inserted and removed according to the last in, first out principle. Just like this, a pair of planes. You can just take out the topmost one. You can't take the second one, the next one, or bottom one. Otherwise, the whole pair of planes will collapse and plung. So, in this case, we can just have two operations available. One is put something to the pair, or what we call stack. Push. The term is called push. Or you pop. Pop means you get one thing from this stack. It must be taken from the top. So to illustrate this example, just like this, okay, you have a stack of cups. Okay, you can see in the restaurant sometimes there will be a cup putting one on top of the others. So here there's a pointer pointing at the top. So if you put one more to this stack, that is, add one more, then it is an action of push, that is, add one more item in the stack. And if you remove a cup from the stack, it means that you must take from the top. Therefore, the action is called pop. So it obeys the principle of last in, first out idea. So with this concept, we can take a look on the actions available. As mentioned, in stack, push and pop are the two main operations that is available. So we can make it as a more formal understanding in the computer science. So as long as we can reinforce first in, last in, first out principle, it becomes a stack. So a stack is an abstract data type, remember the term ADT, that supports the following two fundamental operations: push an object, insert an object O at the top of the stack. So it would have input, that is the object, and the output will be nothing. When you pop up something, you remove from the stack and return the top object of the stack. Just like, okay, you still remember when you get something from a linked list, you're not just removing, but you're getting the content. So it also specifies that an error occurs if the stack is empty. So the input is nothing, you don't need any argument, but it will give you out the object. There are other methods can be supported, just like the term pick, or some textbook or some method we call it top. It returns the top object on the stack without removing it. That's the key difference between the pick and the pop. In pick, it does not remove the top element. And again, an error occurs if the stack is empty. So again, there's no input, but it will give out an object. And another method is empty, or you can name it is empty. okay, it returns a boolean indicating that if the stack is empty, so it will return true or false. And another method that would be optional, okay, many of the implementation will have, is the size. Okay, it returns the number of objects in the stack. So these are the idea of the stack. So if you look at some example just like this one, let's see what is happening. Okay, when we talk about S, this is a stack. Okay, so step by step. First, okay, if you push a number here, then it is pushed to the bottom of this stack. And then if you push one more, just like this 3, it would be put on the top of the stack, about 5. If you pop, then you get the output 3. And the stack will have the 5 remaining. If you push one more, then 7 is put on top of 5. And if you just pop, the 7 will go out. So that's the push and pop. And you can see that this has a top operation. With top, it would just take a look and get the object without removing from the stack. So when you pop it, okay, so 5 is getting out, and the stack becomes empty. And you pop again, it will give error because you are popping an empty stack. So at this time, if you make use of method to check if it is empty, so it will return true, and so on and so forth. Okay, then you push 9, 7, 3, 5. Okay, so at this time, okay, if you implement size, you can get the number of elements in this stack, which is 4. If you pop, you get 5. And if you push it again, okay, then you get 4 elements in the stack. So that's the operation of the stack.